MySQL HeatWave Lakehouse is the latest addition to the MySQL HeatWave portfolio that allows users to process and analyze hundreds of terabytes of data in Object Store instead of importing them into the database. In this episode, we discuss the scale-out architecture and the novel techniques that are used in delivering this best-in-breed data warehouse service with high performance and cost savings. Welcome to First Principles. I'm Pradeep Vincent, Chief Technical Architect at OCI. At OCI, our goal has always been to innovate on behalf of customers. Oracle HeatWave was launched back in December 2020, and it quickly became one of the best scale-out data warehouse products in the industry in terms of raw performance as well as price performance. Today, Oracle MySQL HeatWave announced MySQL HeatWave Lakehouse. To talk about this, we have our SVP of MySQL Database and HeatWave Product Development, Nipun Agarwal, here with us. Welcome, Nipun.
Thank you, Pradeep. Happy to be here.
So let's actually get started with the basic MySQL HeatWave that was launched a few years back. What is that all about?
HeatWave is a fully managed MySQL service from Oracle with an in-memory query accelerator. It provides 4 advantages. The first one is existing applications which run on MySQL or MySQL compatible databases, when they migrate to HeatWave, they find a significant acceleration in performance because of the in-memory query accelerator. The second aspect is HeatWave provides real-time analytics, meaning that any changes which are made to the MySQL database are propagated in real time to the memory of HeatWave. And not only does HeatWave provide real-time analytics, it provides the best performance and best price performance in the industry for data warehousing. Third, HeatWave provides built-in, which is in-database machine learning, which is fully automated. And finally, HeatWave has support for Autopilot, which is machine learning-based automation. So based on the user's data, based on the user's query, the system learns from it and gets more intelligent over time. So these are the 4 basic advantages of MySQL HeatWave.
Cool. So let's actually go a little bit deeper into how the high scale or high performance at scale actually is achieved in MySQL HeatWave.
So the way we achieve such good performance and such good scalability with HeatWave is by having a massively partitioned architecture. We read the data in very fine chunks, and the data is partitioned based on the query characteristics. Secondly, the size of the partition is such that it can fit in the L3 cache of the underlying compute. And finally, we have innovated on algorithms such that we can process these partitions at a very efficient rate. So for instance, if there are filters in the query, we are able to process them at near memory bandwidth. If there are joins or other operations, we try to process them at near network bandwidth. So the key to achieving scalability in HeatWave is the massively partitioned architecture of HeatWave, whether it's reading of the data, processing the data is done very efficiently with these partitions.
So you actually try to partition this data so that it actually fits into the L3 cache of the CPU, which is really not that big. So you must be doing a lot of fine-tuning to make that work.
That is exactly right. So one of the key things by which we are able to achieve that is that when we are reading the data, we're not partitioning the data based on a static scheme. We are partitioning the data based on the user's query. So if you find that in a given workload, the user is doing a join on a specific predicate, which appears very often as expensive, we will partition the data based on that key. And as a result of that, we are able to use the L3 cache very judiciously, and we use it for operations which are going to matter the most in terms of the cost of execution.
But how do those transactions work? Particularly, let's say we have a transaction that has reads from the HeatWave and also writes into the database entries. How do they stay in sync?
One of the very differentiated capabilities of MySQL HeatWave is that it offers real-time analytics. Any changes or any emails which come to the MySQL are persisted right away, right? So what this ensures is that the transaction processing rate remains unaltered. These changes, once they are persisted in MySQL, are propagated to the memory of HeatWave right away. Now, there is some delay from the time the changes are persisted to the time these changes are propagated, right? It could be a couple of milliseconds. During that duration, if any query comes in to HeatWave, that query waits for these changes to be propagated. So what this ensures is that Any query which comes in after the changes have been propagated will always see the latest and the greatest data. And if there's any query which was already in flight before the changes were made, that query obviously goes through completion without any interruption. So this is how we ensure that we don't degrade the transaction processing rate of MySQL, yet offer real-time analytics.
And that's why you can actually run transactions that cut across database and the HeatWave.
That's right.
So today we launched Oracle MySQL HeatWave Lakehouse. What is this new Lakehouse service all about?
So Pradeep, there's a large amount of data which resides in files in a variety of file formats in Object Store, and this data is typically not analyzed. So the idea over here is to be able to leverage all the scale out, all the query processing capabilities of HeatWave on data which resides in the Object Store in a variety of file formats. So the key thing to note over here is when you have data, and this could be hundreds of terabytes of data in the Object Store in variety of file formats, CSV, Parquet, or like export from other databases, the existing HeatWave engine can be used to process this data without copying this data into the MySQL database. So the key thing over here is that the data in the Object Store remains in the Object Store. We leverage the querying capabilities of the HeatWave engine, and the data is never copied to the MySQL. It remains in the Object Store. And the other aspect is that all of this is done adhering to the MySQL syntax. So we don't have any proprietary syntax. We use a standard SQL or standard MySQL syntax for querying the data, whether it is in the database or it's in the Object Store. Now, one of the characteristics over here is that if users want, they can combine data which is in the Object Store with the transactional data which is in the MySQL database, and hence the term Lakehouse. So what we are providing in a nutshell with HeatWave Lakehouse is the scale-out querying capabilities of HeatWave on data in the Object Store, along with the data in the MySQL database.
So let's say I have I'm a customer and I have like half a petabyte of CSV data in Object Store. What happens behind the scenes in Lakehouse service?
It's a very straightforward process, Pradeep. Like all customers of HeatWave, they can have data stored either in the MySQL database or they could be data in the Object Store. In order for them to process data which is in the Object Store, there are two simple steps. The first thing is that they invoke the Autopilot advisor. Now this advisor does a bunch of things. For instance, based on the data, it makes a recommendation as to what is the size of the cluster which the user would need. In addition to that, it provides a bunch of other information that what is going to be the appropriate data type mapping of the CSV file to the appropriate constructs in the MySQL database. So note, the data is never copied from the Object Store to the MySQL database, but the mapping needs to be defined. So for instance, what is text string going to correspond to? So Autopilot makes a bunch of these recommendations. And once Autopilot has completed, the next thing which the user needs to do is to invoke the alter table command. This is the same command which the users of MySQL currently invoke to load data from the MySQL database to HeatWave before they can run query. And they need to run the same command to load data from the Object Store to HeatWave. And once that is done, the system is ready to run queries. So two simple steps: invoke Autopilot to get the appropriate recommendations and the mapping information. And then the second step is to load the data with the alter table command.
You mentioned, the Autopilot doing schema mapping. That actually sounds very interesting because, without, automation around that, it's going to be a very painful process for me as a customer. So can you talk about how that works?
Yes. One thing to note is that if there is a file, say a CSV file or a Parquet file, the system needs to know, like for instance, how many columns are there? Like what is going to be the data type mapping as such? And the unique thing about MySQL Autopilot is that we are not just reading the metadata information of the file in the case of, say, Parquet. What the system does is the system samples the file, whether it's a CSV file or a Parquet file, and based on that, it comes up with a bunch of predictions or recommendations. And this is done using machine learning information in Autopilot, where it is sampling the file selectively and then coming up with these predictions. And this is fairly fast. So if you have about, like in the example you were talking about, half a petabyte of data, we see that we are able to make this prediction, or Autopilot is able to make this prediction on a half a petabyte table in under 2 minutes.
That's real fast for half a petabyte data. How is it possible that we are actually doing this in less than 2 minutes?
In some sense, we are getting best of both the worlds. First, this is not based on just the metadata. We are actually sampling the file, which means we are going to make very accurate predictions, right? It's not just based on metadata. The way we are able to sample such a large file and do it so efficiently is because we use a pretty novel technique called adaptive sampling. And at a high level, what that means is that we start reading the file. Let's say we are reading, let's say, every 1,000 rows. And what the system does is tries to see that when the statistics or the information which it's retrieving from the rows starts to converge, it can adjust the sampling size accordingly. So if it finds that as it's reading more rows, it's not getting any different information, it can increase the sample size. On the other hand, if each of the rows it's getting has new information, it is going to reduce the sample size. So this ensures that we get very accurate information/statistics. At the same time, it is very efficient. And again, this is not just looking at the metadata, this is looking at the entire file, but sampling it in an intelligent manner, which depends upon the data, which is unique to each of these files.
Going back, you mentioned the second command or the second step as a customer I need to do is alter table, which essentially loads the data. Can you talk about how that works?
Now, one of the very flagship characteristics of HeatWave, which we talked about earlier, is that the query processing of HeatWave scales very well. When the data resides in the object store, the opportunity which we had is to build a system for loading data, which scales also very well. So the way we went about doing this is, first we take the data, which we are reading from the object store, and we break it into very fine chunks. As we load each of this data, when I say load, there's some transformation involved, right? Because we will take the data, we will transform it into some representation. Each of these chunks is assigned to a pool of cores, which is the same HeatWave cluster on which we are going to be running queries. And the rate at which we are reading data from the object store, this is based on an adaptive data flow, a mechanism we came up with in collaboration with the OCI Object Store team. And the rationale behind this is that given a region, the object store performance characteristics are going to be different, like both the number of requests per second or the bandwidth. So the idea over here is to be able to load the data from the object store at the maximum possible throughput without suffering any, or without impacting the SLAs of other customers who may also be running in that region. The adaptive data flow technique is very unique because we are able to do that not just at a node level, but we do it at a cluster-wide level. So as a result of this, what we get is we get very good performance to load data. We do it in a scale-out manner, and we use up as much of object store bandwidth as there is available without impacting the SLAs of other users who may also be using the region at that time.
So, you mentioned, we have a really fast data loading process. That's great. But then what happens after we load the data? So from a query processing perspective, compared to the traditional HeatWave, where you actually load data from database versus, the Lakehouse, where we actually, load it from object store, do I actually lose out anything if I actually, load it from object store?
So this is an interesting question, Pradeep. Like, as I mentioned in the introduction, HeatWave provides the industry's best performance and price performance for data warehouse. And this is something which we are very proud about, our customers rely on. So when the data is coming from the object store, customers get faster load performance without any impact to the query performance. So the query performance is going to be identical whether the source of data is the MySQL database or the source of data is the object store.
Got it. That makes sense. So you mentioned Autopilot in the past and a couple of different times. What exactly in the Autopilot that actually helps us achieve the same query performance?
We are using the same HeatWave engine, the same HeatWave query engine for the data being inside the database or when the data is coming from the object store, right? So that's the first thing. So that ensures that customers get the same semantics and such. But Autopilot is really key for us to achieve the same query performance on data in the object store in two ways. The first one is during the load. So when a query optimizer comes up with an execution plan, that's based on the statistics, right? So statistics are very key for any query optimizer. When the data is stored inside a database, the system has a lot more statistics for the table, but files don't have all those kind of statistics. So the first thing is during the load process, Autopilot intelligently comes up with the statistics and aggregates them such that by the time the load is done, the system has pretty accurate statistics, right? So the files may not have all the statistics, but as we are loading, Autopilot looks at the various statistics, makes some predictions, does the aggregation. So at the end of the load operation itself, we have pretty accurate statistics. So the query plans are fairly good. That's the first aspect. The second aspect is in Autopilot, we have a mechanism by which the query plans can take input from the previous query executions, right? So it's like a query plan improvement. So even if some of the statistics are like not very accurate, as we run queries, the system learns from these previous queries. For instance, what is the selectivity of the various predicates? What was the intermediate result size of the previous queries? And it uses that information to make the system more intelligent. So one of the very unique characteristics of HeatWave is that the system learns over time. The system becomes more intelligent over time because of Autopilot. And this Autopilot capability comes in really, really handy when we are doing processing of data in the object store. And note that these are all machine learning based techniques. So as we improve upon these models, they make the system even more accurate.
All right, so when we are talking about HeatWave, a few minutes back, you mentioned something around overlapping compute cycles and network communication in order to drive the maximum efficiency and performance. Does that actually help with Lakehouse use cases as well? And if so, how?
So when you have a query processing over 512 nodes, right? That's a very, very large scale out system, and a single query runs on all of these nodes. So it is very important to make sure that the scalability of the systems is good. So one of the techniques I talked about is partitioning. But the second important technique which we use is to overlap compute with communication. And what that means is that in any distributed query processing, some of the time in the query processing is being spent in the compute, but some of the time is being spent in either sending data to the other node or fetching data from the other node. What we have in HeatWave is a smart scheduler which tries to overlap this compute time with the communication time. Meaning that as I'm waiting for some data, or as I'm sending some data, there is some task which I have, which I can execute in the meantime where I'm using the computation. And one of the ways which we achieve this very good overlap is because we take the query processing tree and we break it down into very fine-grained tasks. So the fact that we have fine-grained tasks plus an intelligent scheduler which tries to overlap compute and communication is how we are able to get very good scalability, because the network wait time we have is very minimal for the entire query.
How does HeatWave Lakehouse handle the outliers?
Right. So there are two ways to measure the execution time, right? One could be the average execution time, which is also measured as geometric execution time. And the advantage of this metric is that it prunes out the outliers. But then, as you pointed out, if you look at the total execution time, even if you have an outlier, that can completely dwarf the performance of the entire system. And it could be the case. And we find that to be very often the case, that customers may have 2 or 3 long-running queries which completely pull down the performance of the system. So what is very important for us is to make sure that our average time, say the geometric mean, is very good. At the same time, the total elapsed time is also very good. One of the ways we achieve this is by having a very good optimizer called the hypergraph optimizer. So this is an optimizer which is a multi-engine optimizer between the MySQL engine and the HeatWave engine. And it does 2 things. The first thing is it has a very broad search space. So if you have a query, if you have some amount of data, the options it comes up with to explore the search space in terms of the query execution options, it has a pretty broad search space. But the second characteristic is that it's able to prune out those plans which are not going to be very efficient. So what you find is that we are able to explore a very large search space with a hypergraph optimizer, and we are able to converge to the plan which is going to be most efficient very, very fast. So this is one of the ways we are able to achieve very good performance even when you have large amounts of data, where if you were to take a suboptimal plan, the cost of that would be very high. So hypergraph has been very beneficial in us achieving very good total execution time as well.
I think I've heard a lot of innovative techniques that we used in HeatWave and in HeatWave Lakehouse that really help us deliver the maximum performance and the price performance. Thank you for joining us today, Nipun.
Oh, thank you for the opportunity, Pradeep. It was great, as always, to have a conversation with you.
So for MySQL HeatWave, it really has a scale-out architecture for query processing that essentially partitions the data, uses L3 class placement level optimization to really improve the query performance. And then we have Autopilot that really figures out how to use the metadata the best way possible to figure out the cluster size as well as figure out how to do the partitions so that the optimizations work. So that's a key part of HeatWave. And then a key differentiator of HeatWave itself is essentially the full transaction processing into HeatWave that cuts across the MySQL database and HeatWave cluster, which I think is pretty cool and innovative. And then with the new HeatWave Lakehouse, now we have the ability to process data from object store without having to load them into a database. And when we, there's a whole bunch of new techniques that has gone into this, adaptive sampling, which really helps, figure out very efficiently, very quickly when you have, hundreds of terabytes of data in object store, the best way to actually load the data and then eventually query it. So again, Autopilot comes into the picture and it actually does, all the magic here. And then the scale-out architecture, is also adapted to the Lakehouse use case. Particularly for downloading data, if you will, from object store where there's like a maximum parallelism, and we have some secret sauce innovation going on between MySQL Lakehouse and OCI Object Store to really maximize the bandwidth. And then last but not the least, we have hypergraph optimizations to make sure that the query performance is really top notch, even at the outliers at TP90 or TP99 level.
Hey, did you like what you learned? Make sure to check out this video or this link, and of course, subscribe now.